Hello and welcome. In this video, we're going to set up HSRP, STP, and a port channel. Awesome. As you can see, we only have 4 switches and only 2 VLANs to worry about. We're not going to worry about this top part with the firewalls and stuff. We're only going to focus here. So the lab consists of making core A the default gateway for VLAN 10, and core B the active default gateway for VLAN 20. And to make things more efficient, we're also going to set up STP to match the HSRP settings. What I mean by that is to set core A as the root bridge for VLAN 10 and the root bridge for VLAN 20 on core B. And then we're going to set up port channels between core A and core B. And that's it. Awesome. So let's get started. I already opened up my PuTTY connection to the switches. And actually what I'm going to do is I'm going to set up this in a 4-way split to match the lab. So we got core A on the top left, core B on the top right, the sales switch on the bottom left, and then engineering on the bottom right. Awesome. So let's just set it up this way. That way it's a lot easier to jump from switch to switch, sales and then engineering. Awesome. So first things first, we're going to set up the host name on the switches. As you can see, they have generic host names. Of course, you want to set up specific host names for each switch, so that way you know what switch you're in, and also it helps with CDP, finding neighbors in CDP. Like for example, if I do show CDP neighbors, you'll see that the device all have the same host name, which you can't. It's really difficult to tell what switch is switch, right? So config T host name, and this is going to be core A. We go on core B and do the same. Host name core B. We go on sales and do host name sales. Go on engineering and do host name. And for this, I'm just going to put it as eng. Actually, I'm just going to copy this and then paste it. I didn't want to type engineering because spelling is not my forte. Anyways, okay, awesome. So we got that done. So let's just go back to the end. Cool. So next step is to actually set up the VLANs, because we don't have VLANs currently on any of the switches. As you can see, we got the default ones. So we're just going to create VLAN 10 and 20. And we can do this various ways. We can manually type it out on each switch. We can also put it down on a notepad or on your notes and then copy and paste, right? But for this lab, we're actually going to set up VTP. And we're going to make core A the VTP server and then everything else the client. Obviously, this is ideal for networks where you have a lot of switches. For example, you don't want to manually have to copy and paste your configs, your VLAN config to each switch, right? On this lab, it's feasible because we only have 4 switches, but imagine you had 1,000 switches. It's going to take a while for you to copy and paste. And of course, doing it manually is even worse because you might make a mistake. So for that, we're going to use VTP and have VTP propagate the VLANs. So let's go on core A and make this a VTP server. Now, of course, once we type this command, it's going to say that this is already set up as a server because that is the default mode on VTP. So we're good on that. We also have to set up a domain, and we're going to call it lab. We're going to set up version 3. And why version 3? There's 3 main reasons. One, on version 3, you can actually disable VTP. So in the future, you don't want to use VTP anymore. You can disable it with the command VTP mode off. I'll show you that. We have various options: client, server, transparent, and off, which essentially disables VTP. So by setting the version to 3, that gives us the option to disable it in the future if you want. And we also, on VTP version 3, you get the chance to set up a password, which we're not going to do any of that in this lab, but the option is there for the future. So VTP version 3. And last thing we got to set up is a domain, which I already did, I think. Just make sure. Lab. Yes, okay. So we already did that. Awesome. Cool. Okay, and since the VTP commands are going to be the same for everything else, we're just going to paste it or write it down here in Notepad. And then copy and paste. So VTP mode client, because the other switches are going to be clients. VTP version 3. VTP domain. Lab. Okay, cool. And just to clarify, these settings, the settings that we set up on the VTP server have to be the exact same on the VTP clients for them to propagate and sync up the VLANs, of course. The only difference is that we're setting everything else as a client and not a server. So let's do that. Let's go on each of the switches and paste this in. Paste that in. Paste that in. And if we do show VTP status, if I can type, okay, so I typed that wrong. Let's show VTP status. And you can see our version is set to 3. Did we not set the version 3? It says here version running. What about this? Show VTP status. For whatever reason, it says it's running version 3. Even though we specified here version. It says it's running version 1, even though we specified version 3. Not too sure what that's about. Okay, let's just type it again. Okay, now it says version 3. I'm not sure what happened with the last command we ran. Probably some sort of glitch. And if we do show VTP status, it's version 3 on engineering, version 3 on core A, or core B, sorry. And then it should be the same for core, or for cells, yeah, okay. And they all have lab as the domain, so all the settings match. So we should be able to propagate the VLANs. Okay, so let's go on VLAN, or on core A, and set up the VLANs now. So VLAN 10, we're just gonna say it's for cells. If I can type. Let's say your VTP client configuration is not allowed. Let's see here. What did it say? VTP configuration not allowed when. Okay, so we got to set this as a primary. So we do that by saying VTP primary. And let's just wait for that to get set up. And now if we go to config T, say VTP or VLAN 10, sorry. And now we are able to make the VLAN. So what happened here earlier is that sometimes there's a problem where you set up where you got to put the server as the primary VTP. So if you ever see this error, just know that you have to run VTP primary on exec, not on config mode, but on exec mode, and then that'll allow you to create the VLAN. Cool. And now let's create VLAN 20, which we'll name it engineering. And like I said earlier, my forte is not spelling, so I'm just going to copy this. Nice. Okay, so that's that. Now if we do show VLAN brief, we should have 2 VLANs, engineering and sales. And if we do the command on this other switches, we're gonna see somebody knocking on my door. We're gonna see that the VLANs did not propagate. And if you have been studying for your CCNA or know anything about VTP, you know that there's one more criteria that we forget to set up. You can pause the video now and think about it. Okay, cool. So for VTP to work, there's actually a few criteria you have to meet for the VLANs to actually propagate. First is setting up the domain, and then the same version. And obviously, is that how you spell criteria? I think so. Or probably not. Settings to match. So these settings have to match on the switches for VTP to propagate. So one is the VTP domain, second is the version, and third is the link type. So right now, because we haven't set up anything, these links to VTP or Core A, all the links connecting to Core A are set as access and not trunk. And for VTP to propagate VLAN information, these links have to be set up as trunks. So that's why when we ran the show VLAN brief, we didn't see any VLANs propagate to the switches. And so for us to get the VLANs on the rest of the switches, we have to set up these as trunks. So let's do that now. Let's start with Core A and cells. And because these are connected to the same link, as you can see, the link on Core A is Ethernet 00, and on cells it's Ethernet 00 as well. And because it's the same interface, we can actually just set up a single config and then copy and paste it. So the command are interface Ethernet 0, switch port, trunk and cap, .1Q, and then switch port trunk or mode trunk, and then switch port no negotiate. If I can type, negotiate. I think that's how you spell it. Awesome. So we're going to copy that and then paste it on Core A and cells. And as soon as we set up these as trunks, you'll see that on cells, the VLAN information will propagate. Awesome. And now we're going to set up the rest as trunks. So from Core A to engineering, we're going to set them as trunks. Let's see. So that's the command. We're actually just going to change the interface. So for engineering, it's Ethernet 01, and for Core A, it's Ethernet 3. So we're going to paste this first one on Core A, and the second one on engineering. And if we do show VLAN brief on engineering, you'll see that now we also have the VLANs over here as well. Cool. Next step is to set up trunks between Core A and Core B. But we're actually going to set up that trunk on port channel 1. So first we have to create the port channel. And to do that, it's config T. And we're going to group Ethernet 20, 20E, or Ethernet 20 and Ethernet 21, and the same on Core B. So it's actually the same interfaces, so we can actually just set up one config and then copy and paste. Cool. So we're going to say interface range, because we're trying to configure a range of interfaces. This is how you select multiple interfaces at once, instead of having to go by one. So we're going to say 0 to Ethernet 20 to 21. We're going to say channel group 1 mode, and we're going to say mode active, because we're going to set up LACP for the port channel. Now, of course, for LACP to work, one side has to be active and the other as passive, or both sides can be active, and they'll still form a port channel. If both sides are as passive, it won't create a LACP port channel. So to make up a port channel, we actually have two options, which is active passive or active active. And to make things easier for us, we're just going to say active active on both sides. That way we know it's constantly trying to negotiate a port channel. Cool. So we're just going to say active. And you can also select LACP. But just to make sure, like I said earlier, we're going to set it as active. Okay, cool. So we're going to copy that on the switches, and where we're at it, I'm just going to go ahead and enter port channel 1, configure it as a trunk, but first we have to set up the encapsulation type, which is .1Q, or the tagging type, which is .1Q, switch port mode trunk, switch port no negotiate to disable DTP. And that's it. Awesome. And that is it. So that's the config, and we're going to copy and paste on core A and core B. And then we made a mistake somewhere. We mistyped encap. And we did another error here, which says core A. For some reason, I've noticed that it's copy and pasting between these nodes doesn't work very well. Okay, now it worked. Cool. As you can see, sometimes it makes this huge space. Okay, that worked. Nice. And to make sure that everything's correct, we can check the port channel, or the ether channel, by saying show EtherChannel brief or summary, just to get a better outlook here. And as you can see, it's SU, which means S means for layer 2 and U means in use, which means our port channel is in use. Let's do the same on core B. And as you can see, SU, the same. S for layer 2 because our port channel is layer 2, and U for in use. Cool. And if we check the VLANs on core B, we should have VLAN 10 and 20 on here. Sales and engineering. Cool. Awesome. Nice. Okay, that's that. So now we have the VLANs propagated. We have a port channel between core B and A. We have trunks between all the switches. And let me check my lab notes to see what's left. Okay, next step is to set up SVIs for VLAN 10 and 20 on each switch, just on core A and B. So that's that. Cool. Let's go on core A and set up SVI. So the config is, I'm just going to type it here because it's a lot easier to just copy and paste. So it's enable config T, interface VLAN 10. We're going to say IP address. What is the IP address? 10.10.10.1. And then the subnet of 10.10/24. Nice. And then we're going to go on VLAN interface VLAN 20, create it, and then have the same IP. The only difference is that we're going to change this third octet to 20. Right? 10.10.21. Yes. Cool. And just for good measure, I'm going to say no shut. And that should set up the SVIs. And we're going to say do show IP in brief to make sure that they come up, or verify that they came up. Okay. So we're going to do that. And they should have an SVI for VLAN 10 with the IP, and it's up, and the same for VLAN 20. Nice. Now let's make the SVIs on core B the same. The only difference is that we're going to change the IPs, of course, because we don't want to have duplicate IPs. So the IPs for, let me just delete these for core B. For SVI 10, it's going to be .2, and for And for SVI 20, it's going to be .2. Nice. Pretty simple enough. I'm going to copy that, paste it here. As you can see, we now have an SVI with that IP and it's up. That's for VLAN 10. And then for VLAN 20, that IP and it's up as well. Nice. So the SVIs are now created. Next step is to set up HSRP. Nice. Okay, so for VLAN 10, the default gateway, the active default gateway is going to be core A. And then the standby is going to be core B down here. As you can see. Cool. Awesome. Okay. So let's go on the SVIs and set up HSRP here. Now, why you can set up HSRP on any layer 3 interface, which is going to be an SVI or a physical interface. Now I'm going to set it on a SVI because since it's half virtual, it's not common for an SVI to go down because there's no physical link connected to it. If you were to set up HSRP on a physical link, for example, on this, on this link connecting the core A to the switches, then this physical link could go down, and then you would have a problem. You would have a physical problem with the link going down, of course. But of course, even if the link went down with a physical link, then the standby would take over, which in our case is going to be core B for VLAN 10. But anyways, we're going to set up HSRP on the SVIs because we know for sure it's less likely to go down than a physical interface. Okay, cool. So the command for that is standby IP, and then we're going to set up the IP. The IP for HSRP on core A is going to be 10.10.10.254. So 10.10.10.254. So that's that. If we type it right and not fat finger this, nice. As you can see above, we fat fingered it and we put 10.01. And then we got this error saying that the standby IP has to be within the same subnet. And that's referring to our SVI. If you remember earlier, we set up VLAN 10 SVI as 10.10.10.1/254. Sorry, 10.10.10.1/24. That was the network. And so our HSRP IP has to be within that network. Otherwise, it'll give you this error saying that you can't put this IP because it's not within the same subnet as the interface, which is in our case is the SVI. Cool. Okay, so next we're going to set up the priority. Did we forget to put this here? Actually, I'm going to go up here and do no standby because I forgot to put the group or the standby number, which is 10. Okay, nice. Now this IP is set up on standby 10. Earlier I forgot, as you can see, and it probably put this IP on the default standby number, which is 1, and we don't want that. We want it to be on 10. Okay, nice. And now we're gonna go on core B. Or no, sorry, we're gonna set up this as standby priority. Standby 10 priority, if I can type, and we're going to set it to 10 above the default, which is 110. The default priority for HSRP is 100, but just to make sure that core A is the active for our HSRP 10, which is for VLAN 10, we set it to priority 110, which is 10 above the default of 100. Nice. So that's that. Another common thing to do is set the active as preemptive. That way, if it ever goes down, the standby is going to take over. But once the active that was active in the first place comes up, it'll take over again, and that is fine. But the problem is that if for whatever reason core A is going up and down, the default gateway is going to keep transitioning from core A to core B, core A to core B. And it's not really ideal because that may introduce latency in the network. So we're actually not going to set up preemption on any of the switches for that matter. Cool. All right, so let's go on core B and set this up as the standby for HSRP 10. So we're going to go on VLAN 10 again. We're going to say standby 10 IP 10 254, right? Just to make sure. 1054, yes. And of course the IPs have to match. That way that the switches know that this is the primary and this is the secondary. Or the switches know what this standby is for, right? For which IP. And then we're going to say 255, or we don't have to set that up actually. And now we're going to say standby 10 and priority 100 just to make sure. That way it actually is a standby. And I know for sure it'll be the standby because it has a lower priority than the active. And that is all. Well, there's more settings that you can set up, but we're not going to worry about that today. That's all. As you can see, it's the standby, and we can verify that by saying show standby. If I can type standby, I can't remember if it's brief or summary. It's brief. As you can see, it says here for HSRP group 10, it's on the SVI 10, priority 100. The standby is the local, which is core B, and the active is 10.10.10.1, which is core A. And our virtual IP is for group 10 is 10.10.10.254. And if we do the same command on core A, you'll see it'll say that it's active. Active equals local, which is core A. The priority is 110, which is above 100 on this other side. That's why it's the active. The standby is 10.10.10.2, which is core B, and then our virtual IP is 10.10.10.254. Nice. And this is going to be the default, the IP we set as a default gateway for computers on VLAN 10. That way all traffic is sent to core A because it'll be the active default gateway for VLAN 10. Cool. So that's for VLAN 10. Now we have to do this exact same thing for VLAN 20. But it's actually going to be the opposite. We're going to make core B the active for VLAN 20, and then we're going to make it, and then we're going to make core A the standby for group 10 or group 20. Sorry. Nice. And of course, we're going to set that up on the SVI 20. So we're going to say standby 20. IP 10.10.10 or sorry 10.10.20 2254. If I can type that, and then I'm gonna say 20 priority 110 just to make sure it's actually gonna be the active router, and that's it. IP pretty the IP and the priority. Nice. Okay. And as you can see, after a while, it actually becomes the active. Well, it's because it's the only switch or router on group 20. That's why it became active. Anyways, we're just going to set up the opposite on core A. Interface VLAN 20. Standby 20. IP 10.10.20 254. And then we're going to manually set the priority to 100. That way we know for sure the priority is lower than core B. And that should propagate here in a second. There we go. Oh, no, that's something else. We can do show standby brief. Okay, cool. And as you can see up here, it actually propagated. Even though it says stand byte. Okay. Or that was, sorry. Anyways, For HSRP group 20, we can see this is the standby. Core A is the standby. The active is 10.10.22, which is core B. The local is core A because it's the standby. And it's for virtual IP 10.10.22.54. Cool. If we run the same command over here, it should be the same. Standby brief. If I can type, it'll be the active for group 10, priority of 110. The local, the active is local, which is core B. The standby is 10.10.21, which is core A. And then the virtual IP for this group is 10.10.22.54. Awesome. So that's that. So now we actually, the only thing that we have to set up now is STP. Nice. Okay. So I'm actually going to start separating these to make more sense. That way it's not that piled up. Okay, the last thing to do is make STP match our HSRP settings. And the reason for that is we want STP to be set up a way where it sends traffic the most optimal path. So I know if I set core A as the root bridge for VLAN 10, then these for core A, I know for sure engineering is going to take this path to core A directly, and sales is also going to take this path to core A directly because it's the root for the VLAN. And that way it's not hopping from engineering to core B and then to core A. It'll just go directly to core A for traffic and VLAN 10, of course. And then the opposite is true for VLAN 20. We're going to make core B the root for VLAN 20. That way, when traffic in VLAN 20 wants to go out, it'll go through from sales to core B directly and from engineering to core B directly. Awesome. So let's just make those settings. That way there's a one-to-one mapping between HSRP and STP. Okay, so we're going to set up core A first. STP VLAN 10 root bridge. Cool. So let's do that now. Let's do on core A. We're going to say spanning tree VLAN 10 primary root. And we can set this up as a primary. Or a secondary. Now the problem with this is that it'll set the STP priority to a set setting, which is going to be the lowest for STP, which is 0. Well, I actually don't want to do that because what if in the future I have three switches? As you can see, there's only primary and secondary. What if I want in the future to set up a third switch to act as a tertiary root bridge? Well, if I use primary and secondary, I won't be able to do that because there's only 2 commands for that. There's no root tertiary, right? So what I'm gonna do is gonna actually set up the priority manually, and we're gonna say priority 0 because the lower priority for STP the requirement is for a switch to become the root. The criteria is first the priority. If the priority is the same between 2 switches, it'll go to the MAC address, the lowest MAC address. And we don't want to have that be the case because older switches usually have lower MAC addresses than newer switches. So if we let STP run as it should, most often than not, it's going to choose the switch with the lowest MAC address as the root, which we don't want because older switches are old and they don't have enough processing, or not as much as new switches anyways. So that's why we want to set the priority manually. That way that's the only criteria that STP uses to set up the root bridge, or to know what is the root bridge. Cool. So we're going to set that VLAN 10 priority 0. Now core A is going to be the root bridge for VLAN 10. And for VLAN 20, we want to make it the secondary. And for this, we got to set the priority to 496, I believe. Because the priority in STP jumps from 496. So it's not from 0 to 1 and 2 and 3 and 4, so on. Nope, it's actually from 0 to 496, and then the next priority would be 8,000 something, 100 something, I can't remember. So that's going to be the priority for is going to be the secondary root bridge for VLAN 10. Nice. What that means is that if for whatever reason we set up core A as the root bridge for VLAN 20 and this switch goes down for whatever reason, then core A is going to take over for that VLAN. Nice. And as if you remember earlier, we set up core A as the standby for VLAN 20. So actually, it'll also take over the virtual IP for HSRP 20, and now all traffic is going to go to core A. So that's why earlier I said we were going to set up HSRP and STP mapping 101. That way traffic takes the most optical path if either VLANs go down. Okay, nice. So that's that for VLAN 10 priority. The root bridge for VLAN 10 is core A, and then the secondary for VLAN 20 is core A. Now we're going to do the opposite on core B. We're going to say spanning tree VLAN 10 priority 496. And then we're going to set up for VLAN 20 0. That way it becomes the root bridge for VLAN 20. Nice. And if we do show spanning tree, let's just confirm our settings. So let's see here. Spanning tree VLAN. Okay, so let's just look it up for VLAN 20. For VLAN 20, you see that this is set up as a root bridge because that's how we set it up. And that's that. And if we run the same command for VLAN 10, you'll see that this is going to be the standby. Or it'll tell us that the root bridge for 10 is going to be the switch with this MAC, which is core A. So we do spanning tree, VLAN 20, or VLAN 10, this is the root. And for VLAN 20, it'll have the MAC address of core B. Nice. Okay, so our root bridges are set up. That's that. So now the last thing we have to do is actually nothing. We're done with core A and core B. We did the port channels, VTP, the SVIs, HSRP. We verified that information. We set up the STP VLAN for each. Trunks between switches, and the same on the core B. Nice. Okay, so last thing to do, and for of course for sales and engineering, we set up VTP client 3. They got their VLANs. They're on trunks. Nice. Okay, last thing to do is actually configure the. I'm gonna copy this and delete it on this main. That way we only have the last information that we had to set up. So on PC 12, which is going to be PC 1, I changed the name earlier. Let me actually just change that to make it less confusing. So on PC 1, we're going to set up the link between the cells and the PC as VLAN 10. And then on PC 2, the link between engineering and PC 2 as 20. Nice. So let's go ahead and do that. And while we're at it, we're actually going to set up STP port fast and STP BPDU guard. Or not bodyguard, BPDU guard on the interfaces. If you don't know what STP port fast is, it'll transition this link into the forwarding state immediately. Usually that doesn't happen because STP is doing its calculations to see if that link is going to create loops, but because end hosts don't understand STP information, it'll never create loops, right? And so that's why we set it to the forwarding state immediately, because we know it's not going to create loops. Nice. And just in the case that for whatever reason in the future, maybe someone in sales finds a switch, and plugs it into this interface, that switch is going to start sending BPDU messages and potentially form a loop. And so to prevent that, we're going to set up BPDU guard. That way, if this link ever receives a BPDU message, it'll transition the port to error disable, essentially turning the port down, and it won't create any loops. Awesome. One last thing to mention is that if this ever happens, the port is going to stay down until you manually put it back up. If you don't want to manually put it back up, you can do something like error disable cause BPDU guard, and then say error disable recovery, and then set up the seconds. That way, what these commands essentially do is it automatically brings the port up. If the cause for error disable was a BPDU message, it'll bring the port back up within, let's say, 400 seconds, which is like 4 minutes or something like that. No, it's not 4 minutes. It's more than 4 minutes. It's however many minutes it is. But we don't want to put that up. We don't want to set that up because it's unnecessary for ports connected to end user PCs, because it's not likely for someone in sales or someone in general to plug a switch into an end user PC port, right? Unless you have terrible malicious people as employees, and for whatever reason you have switches laying around. Okay, cool. So let's do that. We're going to go on sales, config T, not interface, Ethernet 01 or 10. E10. Let me just make sure. Yes. E0, we're going to say spanning tree, port fast, enable. If this works. Spanning tree, port fast, edge. Let's see here. Usually you get this warning saying that it'll take effect, that port fast has been configured on the port, and it only will take effect if it's a non-trunking. And that's because you can actually also enable port fast on a trunk link, which is not typically advisable or advised. Anyways, but because this is an in-host PC, we don't really care. And we're going to do the same for engineering. Oh, and I forgot one thing. We actually have to set this up as we're going to have to set up the link between sales and PC1 as access on port 10. Nice, that's that. Let's just make sure that's correct. We should see the port connecting the cell switch to the PC on port 10, which it is. And now we're going to configure the same for PC2, but this time set it as VLAN 20. So Ethernet 10, E10, switch port mode access, switch port VLAN 20. And as you can, and we actually have to set up STP as well. So spanning tree, port fast, edge. And we get the same error, but we don't care because the link is connecting to an host. So that's that. That sets up our requirements here. Last thing we have to do is set up the IP on the PCs themselves. And so for that, we have to log into the devices, or the PCs. Let's just make sure that on the engineering switch, we actually, that the link between the PC and the switch is on 20, VLAN 20, which it is. Okay, cool. Last step is to set up the IPs on the PCs themselves. Now, of course, you could use DHCP on an external server, like a Linux server or a Windows server, or you can set up DHCP on the SVIs on Core A and Core B. But we're not going to do that today. We're just going to set them up manually. And the command for that is let's just do a question mark, because I've never dealt with these computers actually. So it says here to use IP to set up the IP address. Okay, so the command is IP, the address, which is for PC2 is going to be 10.10.20.10. If I can do this properly, 10.10.20.10, and then the gateway, which is going to be, or the mask, which is 255.255.0, and then the gateway, which is going to be our virtual IP for HSRP 20, because that's for VLAN 20, which is 10.10.22.54, I believe. That's the VIP for default route or default gateway for 20. Let's see here. HSRP 20, 10.10.20.20, 10.10.22.54. Nice. And that should work. Let's check in for duplicate IPs. But because we don't have duplicate IPs, we should be okay. Awesome. So that's that. That's for PC2. Let's just make sure we can ping our default gateway. And if we get a success, we know we set this up right. And if we don't, we can troubleshoot. Awesome. But as you can see, we get a ping back, which means it can actually reach our default gateway. Nice. Cool. And let's set up the same for PC2 or PC1, sorry. So IP address 10.10.10.20, 10.10.10.10.10. That's the IP for PC1, I believe. Yep. Default mask of /24, and default the gateway is 10.10.10.254. Check in for duplicate IPs. We shouldn't. Let's ping our default gateway, or our gateway, which is 10.10.10.254. Awesome. As you can see, we can ping it, which means it can reach it, and which means we set this up right. Cool. So that's that. One thing I want to test is that the HSRP is actually working correctly and failing over to the standby. As you guys know, with HSRP, if the active goes down, then the standby takes over as the default gateway for that for that group of PCs that have that virtual IP as their default gateway. So what I'm going to do is I'm going to start a ping for our HSRP 10, and as you can see, it's going fine because it's currently active. And then actually, let's set up unlimited ping so that it doesn't stop. Okay, we can do T. That way, it'll send continuous pings until we stop it. And what I'm gonna do is go on the SVI 10 and shut it down, and we should see this stop for a second. We should see the ping stop, and then after a few seconds start again, because by that time Core B is gonna actually take over as the active for group 10, HSRP group 10. So let me do that right now. I'm gonna go on Core A, interface VLAN 10, and then shut this down. And because it's shut down, then Core B is going to take its time to take over as the active, and as you can see, it's now taken over HSRP group 10. So it started good. It started fine, and then we shut down the port on the SVI active for HSRP 10. It took a while for Core B to take over, and then as you can see, it took over. That's why it's responding back. Cool. So our setup for HSRP group 10 is fine. Now let's test the same for Core B, or for HSRP 20, because for HSRP 20, Core B is the active. So if we go to PC2, it should work with other PCs, but it's whatever. We go on PC2, as you can see, because Core B is currently on, or it's currently active for VLAN 20 for HSRP group 20. It's pinging correctly. But if we go on here and shut it down, the ping should stop like we saw earlier. And then because it takes a few seconds for Core A to take over that group as the active, it'll show as a timeout and then start pinging back. Cool. So let's do that. We go on Core B and shut down SVI 20, VLAN 20, which is where we have our HSRP active set up, or our HSRP settings set up. We'll do shut. We go back on PC2, as you can see, because Core B is no longer active because it's shut down. It's taken a while for Core A to take over HSRP group 20 as the active. And as you can see, it started pinging back. And if we see on Core A, it went from standby to active. So right now it's the active for a group for HSRP group 20. And that's why it started pinging back. So in a nutshell, we set up this correctly, and everything works fine. So to recap, we set up VLAN 10, 20 on the switches. We set up Core A as a VTP server and everything else as the clients. That's how we propagated the VLANs instead of having to do it manually. We set up HSRP for VLAN 10. We set up Core A as the active. And for VLAN 20, we set it as standby. And then we did the opposite on Core B. Active for VLAN 20 and standby for VLAN 10. We also set up STP to match our HSRP settings. That way traffic takes the most optimal path. So for VLAN 10, it goes directly to Core A. And for VLAN 20, it would go directly to Core B, because that's set as a root bridge for VLAN 20. And also the active for VLAN 20. And then the same for Core A, active for HSRP VLAN 10, and the root bridge for VLAN 10. So that's that. We set up port channels between Core A and Core B for, of course, redundancy and also load balancing. And that's it. And we set up STP port fast on PC 1 and 2 because they're any user PCs don't understand STP BPDU messages. And so there's no chance of a loop coming up there. And then for a safe measure, we set up BPD guard on the interfaces connecting to the PCs, just to make sure that in whatever case, for whatever reason, this interface starts sending BPD messages, it'll actually shut down the port, right? That way it doesn't create loops. So that's it. That's the lab. in a nutshell. It did take over an hour, but it just helps you understand and actually implement HSRP, EtherChannels, also known as port channels, also known out of Cisco terminology as lags. And we set up VTP, HSRP, STP, the root bridge, and port fast and BPDU guard. We set up trunks. We set up access mode on the PCs. So yeah, we did a lot on this lab, and I recommend you to actually follow along and do it on Packet Tracer. That way you can understand how to do it, and it makes a lot more sense once you actually start doing it. Anyways, thank you for watching. I hope this makes sense. If you like the video, give me a thumbs up. And if I did not explain something well, if I made mistakes, let me know in the comments. And thank you for watching. See ya.